This is the solution to problem 35 from section 6.7. And here we have to create our own diagram. So we're told that a plane is observed approaching your home and you assume that its speed is 550 miles per hour. The angle of elevation of the plane is 16 degrees at one time and 57 degrees 1 minute later. So I've sketched a diagram here, and we're supposed to approximate the altitude of the plane, which I have labeled Y in the diagram. So I have two right triangles. So this one that I'm going to highlight in blue right now is the first time that you look up at the plane, and the angle of elevation is 16 degrees. And the second triangle, I'm going to highlight that in red right now, and that's the second time you look up, and the angle of elevation is 57 degrees. And here we know the speed of the plane, so we know that distance is equal to rate times time. So the distance, which I've labeled D on our diagram, is the distance that the plane travels between the first and second times we look up, is equal to the speed of the plane, which is 550 miles per hour. And we look up 1 minute later, so I'm going to convert from miles per hour to miles per minute. So in 1 hour, there are 60 minutes. And then I can multiply this by 1 minute because that's the time between our two observations. So that tells us that the distance is 550 miles, because these units are going to cancel out in terms of time, divided by 60. And if we want to get an approximation for that, that's 9.16 repeating miles. So this is D in our diagram. All right, now we're going to use our trig ratios. So I'm going to work with the blue triangle first. So I'm going to say tangent of 16 degrees, and I'm using tangent because we want to know y, which is the opposite side, and we know something about the adjacent side. So tangent of 16 is going to be y over x plus d, but we know what d is, so I might as well put that in, y over x plus 9.16 repeating. And now I'm going to use the second triangle and set up another trig ratio. So I'm going to say tangent of 57 degrees is equal to y over x. We have a system that we need to solve. I'm going to use the second equation, and I am going to solve the second equation for y in terms of x. So y is equal to x tangent 57, and then I can substitute in for y in the first equation. When I do that, I'm going to get tangent of 16 degrees is equal to x tangent 57 degrees over x plus 9.16 repeating. I'm going to multiply both sides of the equations by the denominator, which is x plus 9.16 repeating, which is going to give me x times tangent of 16 degrees plus 9.16 repeating times tangent of 16 degrees is equal to x tangent 57. I want to put both terms with x in them on the same side, so I'm going to subtract x tangent 16 from both sides of the equation, which is going to leave me with 9.16 repeating times tangent 16 is equal to x tangent 57 degrees minus x tangent 16 degrees. In order to isolate x, I need to factor out the x, so that's going to be x times the quantity tangent 57 minus tangent 16 is equal to 9.16 repeating times tangent 16 degrees. And finally, to isolate x, divide both sides of the equation by tangent 57 minus tangent 16. So let me do that. Tangent 57 degrees minus tangent 16 degrees. And then if you enter that into your calculator, you will find that x is equal to 2.098 miles. But we really want to find the height. So to find the height, we have to use the equation that y is equal to x times tangent 57. So y is equal to 2.098 times tangent of 57 degrees. And when you enter that in your calculator, you'll get y is equal to 3.23 miles, which is the height of the plane, or the altitude.